Today's lesson is going to start our triangle congruence unit. Basically, here's your task. If you can get to, there's 5 theorems, and if you can get to one of them, meaning you can get enough information to use one of them, you can go ahead and say the triangles are congruent. So remember what congruent means. It means all the sides and all the corresponding angles are equal. So if I want to know for sure if these are congruent, normally I have to draw tick marks on all the sides and rainbows in the corners. But these theorems are saying, hey, that's actually not necessary. So if you can get enough information to the point where you have 3 tick marks, 3 sides that are congruent, you don't need all the rainbows here. You can actually say, okay, they're congruent because of this theorem. So someone worked hard a long time ago to make this enough information for you to know that everything else could get marked. So the first theorem says if you need 2 triangles, of course, you're trying to prove them that they're the exact same. And you need 3 sets of congruent sides. And what that means for us is 3 sets of tick marks. So you need a tick mark on each of these sides. Then you need 2 tick marks on the other side. And 3 tick marks on the last side. If you can gather this much info, then you can go ahead and say these triangles are the exact same, so all their angles are the same as well. You don't need me to put rainbows in the angles and all that fun stuff. So I usually teach my kids to see tick marks as S's. So every time you see a tick mark, I want you to think S. Here's another set, that's another S. And another set, that's another S. And if you think that way, you can see the SSS theorem taking place. For lack of a better term, I call these markings rainbows. So anytime you see a rainbow, you need to think of the letter A for angle. And that'll help us with the next theorem. So the next theorem we'll be practicing is called side angle side, or SAS for short. You're still going to have 2 triangles, but this time you get 2 sets of tick marks. So there's 2 sets. So again, you want to think in your head S, S. So you don't have SSS yet, so we're going to just freeze the S and S. You also need a congruent angle, or for lack of a better term, a rainbow between your tick marks. And here's what I mean. So in this picture, your rainbow has to go here. It cannot go here or here. And in this picture, your rainbow has to go here as well. So when you see a rainbow, you think angle. And if you do that, you can see the SAS theorem. You can see it in the picture. And that's kind of what we want to train our brains to do, is recognize tick marks as S's and rainbows as A's. So the reason we had to put the rainbow here and we couldn't put it here is both sides of your rainbow have to have tick marks. That's what it means to be in between. So just like it is in the name of the theorem, SAS, that has to be reflected in the picture. The angle must sit between the sides. If I would have put my rainbow not here, if I would have put my rainbow here, well, on this side of the rainbow, you do have tick marks, but on this side, you do not. So actually what you would have here is SSA, not SAS. SSA is not a theorem, so you can't use that. It's really important to get that rainbow in the correct spot. So to make you comfortable, we're going to do some examples of what SAS would look like. So you need 2 sets of ticks. So I'll put one here, and maybe here and here. And then in between your sides, your tick marks, you need a rainbow. So the goal is you want your rainbow to have tick marks on both ends. So it has to be here and here. And you can always double check and make sure you do have tick marks on both ends, but we do have side angle side. In the next picture, when you see a situation where 2 triangles share a side, you have to put your own tick mark in. So I would not mark that for you. You have to know that that's there. The other markings I would have to do for you. So I would have to put tick marks maybe here and here. I would also have to have the rainbow for you. And your rainbow for the left triangle needs to be at the top. And for the right triangle, it needs to be on the bottom. And if it's not there, then you would have SSA, and that's not a good thing. So we want it to be SAS. SAS. In the third picture, we should be used to seeing these angles by now. These are vertical angles, and again, I will not mark them with rainbows. You have to do that yourself. Everything else I would have to mark for you. So I would have to put a tick mark here, and then here and here. And again, we want that angle to be sandwiched between the tick mark sides. Here's some examples of what SAS is not. So you would still have two sets of tick marks, but this is where they try to mess you up. I'll put a rainbow in the correct spot for one of them, but I'll put it in the wrong spot for the other. So if they're not both correct, then it's nothing. You don't have a theorem. You have SSA here and SAS here. They don't match, so you can't use the theorem. Remember that you need to put your own markings here and here, so I will not be marking those for you. And then I would put tick marks here and here, but I'm going to put the rainbows right here and right here. So both of these triangles are not SAS. They are SSA, and that's not good. So that would not be SAS. And then the last picture might look something like this. And again, I put the tick marks on the wrong side. So we do not have SAS, we have SSA. So again, I can't emphasize that enough. Both sides of the rainbow need ticks. So we're going to do 3 proofs and just try to learn what it's like to use these theorems in our proofs. It says, here's your given, and your task is to prove that the triangles in the picture are congruent. In order to do that, we need to get to one of our theorems that we just learned. So we're going to try to gather up info to make that happen. RP and RQ are equal. That is given to us. So you may mark that. It also says M is the midpoint of PQ. So you know right away that you will have to write definition of midpoint. So if there's a vocab word, you have to write definition of that. So here's what you do. You focus on what comes after midpoint, a segment. Okay, so we're going to find segment PQ. When we're dealing with segments, segments get tick marks. So you put your tick marks on both sides of PQ. And then back in your proof, you have to tell me the names of the sides that now have tick marks. So one side is PM, and the other side is MQ. So what I like to do is I look at my picture, and I always try to decide, do I have enough to use SSS or SAS? Well, right now you have SS. That's it. There's no rainbows, and I don't have any more tick marks. So at that point, you need to think, what would Mrs. Stoltz expect me to do on my own? Oh, well, we would mark this side because obviously it equals itself. So we want to say that RM equals itself. And if you don't remember, that is called the reflexive property. So you want to pick up on this yourself. I'm not going to do that for you. And now when I look at my pictures, I see 3 sets of ticks, which is awesome because I can use SSS. So triangle PRM is congruent to triangle QRM because of the SSS theorem. In the next one, it says AB equals BC, so those get tick marks. And I see the word bisect or bisector, so I will definitely have to put definition of bisect in my reason. So again, we look after the word bisect, and it says AC. So that means we find AC, and we put tick marks on both sides. And then we name the sides. So we have AD for one and DC for the other. And again, I look at my picture and I see S, S. That means you must have the third S and be able to get that on your own. So you need to come up with BD equals itself because of the reflexive property. And now that you have side, 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 you're ready to prove the triangle's congruent. So the triangles are congruent because of S, S, S. All right, in the last one, it does say AB equals CD. And it also says that AB is parallel to CD. So I just want to clarify, when you see an arrow, that does not mean the same thing as a tick mark. We do not count arrows as tick marks. Arrows mean parallel. So anytime in these proofs you see parallel lines, you will have to use alternate interior angles rules. So anytime you see parallel, you need to think alternate interior because at some point we're going to need that fact. So right now you have side. That's all you got, an S for each triangle. So there's a couple things you could do. You could talk about the side in the middle, or you can deal with the parallel part. So when you look at parallel lines, okay, since it's the left and the right, we want our rainbows to go between the left and the diagonal and the right side and the diagonal. So one side of your rainbow should have an arrow and the other side should be the diagonal. And you can see that that's happening here. That's how you get the rainbows in the correct spaces. And what I like to do is I like to put a number in here. It makes it easier for me to name the angle. So now I can call angle 1, angle 1, and angle 2, angle 2. These angles are congruent because of these parallel lines, because they are alternate interior angles. So now you have a side and an angle. So I'm definitely looking for a third or a second side. And now we're going to say something about the one in the middle. So BD equals itself because of that reflexive property. And now if you look at just one triangle, so we'll look at this triangle right here. Hopefully you can see that we have side, angle, side going on. So if you have that, you can go ahead and finish your proof. So the triangles are congruent because of the side, angle, side theorem.